Okay, so today going to do problem solving with exponential and logarithmic equations. Okay, and to start, we're going to look at the one-to-one property. Of logarithmic equations. Okay, and all that does is states that if, well, let's say first, if we let our uppercase M be a positive number, our uppercase N be a positive number, our base is a positive number, and our base doesn't equal 1. Then we can say that the log of base B of M equals log of base B of N just means that M is equal to N. So it's similar to, kind of block that off, similar to the one we did before. Where if you have b to the power of x equals b to the power of y, means that x equals y. Same thing, but instead of the exponents, we're applying it to logarithms. Well, as long as the base is the same, the inside of here has to be equal for that to be true. All right, so for our first example, let's say if we wanted to solve 3 times log base 3 of x equals log base 3 of 27. Okay, so here you have a log function equals a log function, so you can kind of combine those. The only thing is you have to get rid of the coefficient first. So first, use the power rule for logarithms. To get rid of any coefficients. Uh-oh. Clean that up a little bit. Okay, so that means our 3 times log base 3 of x equals log base 3 of 27 will just become that 3 goes to the exponent. So it's log base 3 of x to the third equals log base 3 of 27. Okay, so we have a log base 3 and a log base 3 over here. So that means what's inside has to be equal in order for this to be true. Okay, so that means that x to the third equals 27. Okay. So we take the cube root of both sides. So you have the cube root of x to the third equals the cube root of 27. These two cancel each other out. So x is equal to, you have the cube root of 27, since 3 times 3 times 3 is 27, that's equal to 3. Okay. And whatever your answer is, you always want to make sure that if you plug it in, you won't get a negative number. So valid solution, since plugging it in into the original equation will not create the logarithm of a negative number. Okay, so that's always the last step. You always want to plug in your answers to make sure that if you plugged it in, you wouldn't end up with a log of a negative number. Oh, sorry about that. Thought it was up far enough. All right. So any questions so far? All right. All right, so for our next example, so if we wanted to solve 2 times log of base 5 of x equals log of base 5 of 169. Okay, so you have a log function equal to a log function, so that part is okay. But the first thing you have to do is get rid of that coefficient. So use the power rule to get rid of the coefficients. Okay, so that means that 2 times log base 5 of x equals log base 5 of 169 becomes, our 2 now goes up to the exponent. So you have log base 5 of x squared equals log base 5 of 169. Okay, so you have log base 5, so that means these two have to be equal for it to be true. Okay, so that means x squared has to equal 169. So we take the square root of both sides. I mean, x can equal positive or negative 13. Okay, so that means x can equal 13 or x can equal negative 13. Okay. The only thing is, if we plug in negative 13, we'll have log base 5 of negative 13, which is undefined. Okay, so we know that's not a valid solution. Since it creates the logarithm of a negative number. Okay, now if you plug in x equals 13, you're just fine. It's positive. So this is your only valid solution. So any questions on that one? All right. Everyone's still writing. Looks like everyone's done. Okay, so let's say if we wanted to solve log base 5 of 4x minus 5 equals log base 5 of 3. Okay. So this one's pretty straightforward. You don't have any coefficients in front of them. It's just log of a function equals log of a function. So you don't have to use the first step of the power rule. Okay, so no coefficients. To get rid of. So you have log base 5 of 4x minus 5 equals log base 5 of 3. Same log function, which means 4x minus 5 has to equal 3. Okay. And then we just solve for x. So we add 5 to both sides. So we have 4x equals 8. Divide both sides by 4. You have x equals 2. Okay. Now we still have to check it, even though it's positive. Okay. So if we check it, we have log base 5 of 4 times 2 minus 5 equals log base 5 of 3. You don't really have to check the log base 5 of 3, but might as well write out the whole thing. Okay, so here you have log base of 4 times 2, which is 8, minus 5. So 8 minus 5 is 3. So log base 5 of 3 equals log base 5 of 3, which is true. Okay, so it's a valid solution. So x equals 2 is a valid solution. Bring that up. All right, so any questions on that one? All right. Okay, so let's say if we have the example to solve, log base 2 of x plus log base 2 of x minus 3 equals 2. Okay. Now because of that 2, we can't put it into the log of function equals the log of a function form, because that 2 kind of throws everything off. Okay, so we cannot put the equation in the form log base b of m equals log base b of n because of the 2. Okay. If we move this on the other side, it would just be 2 minus log of x minus 3, which isn't in the same form. Okay. So whenever you can't put it into that form, you just have to use the other properties. Okay. So if we have, oh, let me write that. Use other properties. so if you have log base 2 of x plus log base 2 of x minus 3 equals 2, first thing you do is look at that plus sign. Okay. So when you have the plus sign, that means you use the product rule. Okay. So we have log base 2 and log base 2, so we can just go ahead and combine them. So that means you have log base 2 of x times x minus 3. And might as well put the x on this side since it's already there. X times x minus 3 equals 2. Okay. Now once you have it in this form, you just have to remember that log base b, and I'll use m here, equals y is equivalent to b to the power of y is equal to that m. Okay, so we have 2 to the power of 2 is equal to that m there. Okay, so 2 squared equals x times x minus 3. So it's a little combination of a couple of the properties. All right, so if we distribute our x here, we have 2 squared, so we have 4 equals x squared minus 3x. So if we subtract 4 on both sides, that's just 0 equals x squared minus 3x minus 4. Okay, so this factors into x minus 4x plus 1 equals 0. Move that up a little bit. Okay, so that means that x minus 4 can equal 0, or x plus 1 can equal 0. Okay, so if we add 4 to both sides, x can equal 4. If we subtract 1 from both sides, bless you, x equals negative 1. Okay, that means we still have to check them. Oh, well, I already have it rewritten right there. So if we plug in 4, that would be positive and that would be positive, so we're okay there. So it's a valid solution. If we plug in negative 1, we'll end up with log of negative 1, which you can't use. So we know that one's not a valid solution. Since it creates the log of a negative number. Oh, bring that up a little bit. All right, so any questions on that one? All right. Okay, I'm still writing. All right, so the next example. Solve log base 5 of x plus 3 plus log base 5 of x minus 6 equals log base 5 of 10. So again, now if we had just log base 5 of x minus 6 equals log base 10, we'd be okay. We can just say m is equal to n. But that third term kind of messes that up. So we cannot put it into log base b of m equals log base b of n. So we use the other properties. Okay, so if we go ahead and rewrite that real quick. Log base 5 of x minus 6 equals log base 5 of 10. Again, we have our plus sign. So you know if you have your plus sign, that's the product rule. Okay, so that means those two combine to become log base 5 of x plus 3 times x minus 6. Equals log base 5 of 10. Okay, now if you look at it, we have a log function and log function. So now we can use the one-to-one property. Okay, so okay to use the one-to-one property. Okay, so that means since you have log of 5, what's in here has to be equal. So that means that x plus 3 times x minus 6 has to equal 10 for that to be true. Okay. So now we just solve for x. Since this is not equal to 0, we have to go ahead and FOIL this out. So we have x squared minus 6 plus 3, so that's minus 3x, minus 18 equals 10. We subtract 10 on both sides. So you have x squared minus 3x minus 28 equals 0. Then we just go ahead and factor. And that factors into x minus 7 times x plus 4 equals 0. Okay, so that means that x minus 7 can equal 0. Or x plus 4 can equal 0. So if we add 7 to both sides here, x can equal 7. Or subtract 4 from both sides here, x can equal negative 4. Okay. So we have it. Now we just have to plug it in. Make sure that we don't get any negative logarithms. Okay, so if we look at our original equation, I'll rewrite it down here, just so we don't have to keep sliding it up and down. Log base 5 of x plus 3 plus log base 5 of x minus 6 equals log base 5 of 10. Okay, so if we plugged in 7, you'd end up with log base 10 and log base 4. So you're okay there. Okay, nothing negative. Plug in negative 4, you'll end up with log of negative 1 and log of negative 10. So you won't be able to use that one. No, I said 10 and 1. I don't know why I was thinking that. So that one's not valid. Log of a negative number. So this is the only valid solution. Okay. So any questions on that one? All right. Still writing. All right. So let's say for our next example, say if we want to solve log base 7 of x plus 7 plus log base 7 of x plus 6 equals log base 7 of 6. Okay. Now I'll give you a few minutes to start on that one. So let me write this on the board, and I'll put the previous example back up since it's really kind of the same thing. X plus 7. I should probably move that over. Log base 7 of x plus 6. I'm just putting the old example, well, the previous example up there. Since the steps are really, really similar.